right, so today what we're going to do is we're going to learn how to build a watch connectivity app where we're going to learn to send data from our iPhone to our Apple Watch. Now the beauty of this is that we don't need to have physical devices to do this. Our simulators will serve the purpose just fine. And also furthermore, uh, the uh, the Xcode software has Apple Watch simulators. So you don't have to worry about having a physical watch to do this sort of thing. And they will talk to each other and send data between each other using a framework called WatchConnectivity. So that's our goal for today. And we're going to be using these simulators in front of us. Now, the thing is with newer versions of Xcode, you're going to have to create your own pairing. So you may not want to go with the two devices I have in front of you, the iPhone 12 Pro and the Apple Watch Series 6. You might go with your own pairing, and I'll show you how to do that as well. So first things first, what we're going to do is we're going to create a brand new project. Now, I haven't been creating fresh projects for you guys in a while because I figure you know how to make projects by now, but I wanted to show you how we're going to be approaching this. So when you do a brand new project, you're going to go to watchOS now, and you're going to choose iOS app with watch app. All right, you can do a standalone watch app now, but we're going to choose iOS app with watch app so we can get the connectivity going between the two devices. We still have to implement this manually, but we want to have both, want to have all the files we need for everything all together in one project. So I'm going to hit next. I'm going to go ahead and give it a home. I'm going to call it M9 watch connectivity. And we're going to be using SwiftUI. I'm going to stick to the WatchKit app delegate for now. And I'm going to use the language Swift, of course. You don't need to include the notification scene, but I'll leave it in there. You can have a look at what the files are all about there in case you might be interested in adding something more to this application. Hit next and give it a home. All right, so the first thing you're going to notice is there's a lot more files here than you've been seeing for your other for your other projects, right? Your iOS projects, you just saw like content view and a couple other files, and that was it. But now we see a ton of other files. All right. Now, one thing I'm going to point out here is that we have actually two projects in one. All right. So starting with this folder, M9 watch connectivity, down to the info.plist file here. This is one project dedicated to the iPhone itself. All right, so the phone itself. This folder, M9 watch connectivity, watch extension. This down to the I would say push notification payload file is all dedicated to the watch. So any files you want to have for the watch go in this grouping. Any file you want to have for the phone goes in this grouping, and they don't talk to each other. Think of it as like an invisible wall right where my mouse pointer is. Right? There's an invisible wall here. So any files you create on one side don't exist on the other side until you actually go into the compiler settings, which we're going to do today, and make it available. All right. So first thing we're going to do is we're going to start with our phone. All right, so I'm going to organize things a bit. I'm going to create a new folder or a new group here. I'm going to call this views. And I'm just going to drag my content view.swift into here. I'm going to create a new folder as well. This will be called classes. We're going to create a few classes here to do some of the work for us. Starting with content view, I'm going to create a new file. And this will be iOS SwiftUI view. And I'm going to call this program view. Now what we're going to be doing is we're going to create a little mini fictitious conference program app, companion app, just to list out all of the sessions for our conference today. And so we're going to be listing those out here in the content view. But before that, what we're going to be doing is we're going to have to understand in our conference app what data we're sending between the phone and the watch. So we're going to start by creating a model that'll take care of that. So under classes, I'm going to say new file, and it'll be iOS Cocoa Touch class. And I'm going to call this program object. All right, subclass of NS object is perfectly fine. Hit next, give it a home. All right, I'm going to start by coding up this program object. Now it's class program object. I need to make it a public class to make it visible to anybody that wants it. So public class program object extends NS object. Now I'm going to make it an observable object. And I'm also going to bring in NS secure coding. Oops. All right. So observable object, just so that it allows for this object to be visible on both the watch and the phone. And NS secure coding, because what's going to happen is that any data within this object is going to be converted to a set of bytes called data, or NS data, and it's going to be sent over a Bluetooth connection to the phone, or sorry, to the watch. It'll be deserialized on the watch side of things. So it's actually an object that's going to be shared between both the phone and the watch. The phone will be doing the encoding, the watch will be doing the decoding. All right. And so don't worry about the error right now, because it's basically saying that we have a few missing methods. We're going to get to that eventually. So what we're going to be doing is, first off, to make NS secure coding happy, we're going to be saying public static var supports secure coding, and I'm just going to hard code it to true. All right, so I'll get rid of one error eventually that'll hit. Now what we're going to do is we're going to define out our object here. So because it's going to be displayed in a list, it needs a UUID object. So we'll say let ID equal UUID, instantiated. Now the object itself is going to have var title, which will be a string. But in order to make this visible to SwiftUI, we have to make it a published object. So we're going to say at published. All right, so at published var title string. We'll do the same for the other features. So at published var speaker is a string. So title and speaker. And then we'll say published. We'll say var from, so the start date and time. I'm just going to use string. I'm not going to use date. Just keep it simple. Of course, you can change this over to a date object to really play with this after the fact. We'll say published var to is a string. And finally, so till the end time, that's what to is all about. And then finally, published var details, which will be like the details about the session that is in question here. All right. So now we have here our data model. We need to add some support methods this time around. So normally data models, this would be good enough, but because we're doing some special work with this, we're going to be sending this data over a connection between watch and phone. We have to add a few extra things. First off, I'm going to create a little mini constructor here. So I'm going to say func init with data. We will pass in title, string, we'll pass in speaker, string, we'll pass in from, string, to, string, details, string. I'm just going to pass them in and just set them. So we'll say self.title equals title, self.speaker equals speaker, self.from equals from, self.to equals to, and self.details equals details. All right. Now we need a couple of more support methods here to enable encoding and decoding this data. So I'm going to see if my friend Xcode here will add these methods for me. Hit fix, and actually it does. So these are the two methods we need. They got pushed to the top. I don't like things at the top, so I'm more organized with like that. I'm just gonna cut and paste them. So I'm gonna get rid of the word code first of all. I'm just gonna cut these methods and paste them to the bottom of the class, just for organizational purposes. Oh, and they actually duplicated the support secure coding. I'm just gonna take that out because we already have it. I'm just gonna push it down here to the bottom. So sorry about that. I actually want to do init first. I'm just gonna move this above. So I'm very particular with my code here. Just wanted to have it organized. So okay, so now init is going to decode this data. All right. So I'm going to start with Encode. So Encode will actually convert this code over to a set of bytes. And these set of bytes will have will be formed in the form of key value pairs. So what I'm going to do is, so there's an argument passing called coder. It's going to be encoding this data. So I'm going to say coder.encode. We'll say self.title. Give it a key, so for key. I'm going to call it title. All right, coder.encode. We'll say self.speaker. And for key, speaker. Say coder.encode, and we'll say self.from for key from. Coder.encode, self.to for key to. Coder.encode. We'll say self.details for key details. All right. So whenever we're ready to actually serialize this data and send it over from the phone to the watch, Encode is going to be running in the background automatically for us. We're not calling Encode at all. It's going to be running in the background for us. And we'll see at that line, I'll point it out at that point where it's running. Now, if we're on the watch side of things and we're receiving this data as a set of bytes, we need to convert these bytes into basically back into this object, this program object. And that's the purpose of this method init. All right, so it has a coder called, well, it's called a coder here. It's really decoding. So what we're doing is checking to see if it has title, speaker, from, to, and details. All right, it needs to have all of these to be the proper object. So we're going to say guard let, which is like a reverse if statement. We're checking for failure. All right. So let's say title equals coder dot decode object. Inside of it, it's actually for key title. So make sure your keys line up as string, comma, let speaker equal coder dot decode object for key speaker as string. All right, so we got title and speaker. And then we'll move on to let from equal coder dot decode object for key from as string. Let to equal coder dot decode object for key to as string. And finally, let details equal coder.decode object for key details as string. All right. And then on a new line, I'm just going to say else. And curly's will say return nil. All right, this is our error checking here. Otherwise, we have our data here. So what we're doing is we'll do a self.init just to call the super constructor. Then we'll do a self.init with data, passing in title as string, speaker as string, from as string, to as string, details as string. All right. So otherwise, assuming that this all worked, then things should be working okay here. All right, and don't worry about the errors that you're getting here. It's a quick fix. Let's just go and let Xcode take care of it for us. It wants the word convenience. Just hit fix. It's gonna make everything go away. All right, so it just wants that extra keyword in there, which I don't know why I didn't add in itself, but that's okay. All right, so this is our object, our program object. Its purpose is to essentially be sort of the data object that's going to house the title, speaker, from, to, details, but also serialize and deserialize the data going from watch to phone. So it's going to handle all of those things for us. So now let's move on to making a connection, all right, and actually getting a connection to work here. So what we're doing is we're adding a new object to handle all of our watch connectivity and to actually do our data transfer. So I'm going to actually add a new file. So I'm going to right click on classes. I'm going to say new file. And again, iOS Cocoa Touch class. And I'm going to call this connection provider. All right, it's also going to be a subclass of NS object. Hit next, give it a home. All right, so I have this thing called class connection provider as an extension of NS object. We have to jump to project settings for a moment. And we're going to be using a framework called WatchConnectivity, but we have to bring that into our project. So I'm just going to hit over to my project settings. And under general here, you'll notice that there's a few targets here. So under general, I'm going to scroll down to the bottom. And under frameworks, libraries, and embedded content, I'm just going to add WatchConnectivity. So if I search for watch, there's watchconnectivity.framework, hit add, and it's there. All right, now I can jump back to connection provider. And what I'm going to do is I'm going to now add in, well, first I have to import WatchConnectivity. And I'm going to implement, so class connection provider extends NS object, comma, WC session delegate. I'm going to implement WC session delegate. It's going to get upset because it wants to have some extra support methods. If I hit yes or to fix, it's going to add these protocol stubs. I'm just going to get rid of the word code, leave them empty for now. I'm going to push them down. All right. So WC session delegate requires these methods, these support methods. What are they about? Well, they're about the connection between the watch and the phone. So this first one, action did complete with, it's like a method that allows us to execute some code right off the bat when we have a connection between watch and phone. Then there's session did become inactive, which could happen, so for example, like maybe your watch temporarily moved away from your phone, right? It's too far away to have a connection. You could have some maybe temporary saving going on, or some temporary work go on just to protect the data that might be lost between a temporary loss of connection. And then there's session did deactivate, which could happen where like you basically dropped a connection. You're not going to get it back, right? So that sort of scenario. Maybe you've uninstalled the watch or something. Maybe you want to take whatever data there is and protect it and save it and flush it to some sort of database or something. Well, whatever the reason, right? But you have these methods here to support you and protect you in that manner. All right. So what we're going to do is we're going to implement a few class variables here. We're going to say private let session extend WC session, right? This is going to be the object that'll manage our connection and our session between the two devices. Don't worry about the error. We'll come back to those in a bit. Now we're going to say var programs extends an array of program objects. So we just created the program object class above. I'm going to set it equal to an empty array. Now, this is okay. What we're going to be doing here is we're going to be hard coding our data here in programs. All right. But I'm going to create one more. I'm going to say var received programs. It's also an array of program objects. Set it equal to an empty array. I'm going to be doing this because my hard-coded data is going to be under the programs variable. And this object, this class itself, this connection provider, is going to be shared between both the phone and the watch. So the watch side of things won't see the programs, right? Because we're not going to initialize it on the watch side of things. On the phone side of things, we'll initialize it. All right. Now, on the watch side of things, we're going to be receiving our program data from the phone. So it's going to be reading the receive programs variable. So that's why I actually have two variables here. All right. We'll say var last message will be of type CF absolute time. Set it equal to 0. This is sort of like a timer variable for us to brute force and push the data from phone to watch as needed. All right. Now what I'm going to do is I'm going to start with implementing a constructor. So init, and we'll say session, which is of type WC session. I'm going to default it to .default. So if nothing's provided, it'll just initialize itself here. Now to initialize our connection here, we're going to say self.session equals session. We're going to do a super.init to initialize a super constructor. We'll say self.session.delegate equals self. So it basically means there's some support methods in this class. Look within that session needs to look within self. Look within this class for those support methods. Now I'm going to add a couple of debug statements here, just purely for debug purposes. Now we'll say pound if OS is iOS. So on the iPhone side of things, we'll just do a print statement to say connection provider initialized on phone. We'll do a pound end if here. And I'll do something similar for the watch as well. So we'll say pound if OS is watchOS. We'll just do a print here saying connection provider initialized on watch. All right, and then an end if. But the most important line of code at the end of this now is self.connect. All right, but we have to implement a self.connect method. So that's still coming, don't worry. We'll do that right now. We're going to create a method. Right here, we'll say func connect. And inside of this, we'll do a guard statement to say WC session dot is supported. Else, we'll do a simple print statement. WC session is not supported. We'll do a return. Otherwise, we'll do a session.activate. What's going on here? Well, basically, we are initializing. We're trying to well, first off, we're trying to see if this is watchOS 1.0. and not 2.0 and above, because watch connectivity didn't exist for watchOS 1.0. So we're checking here to see if that's the case. Like, this is an old watch, which now is getting less and less likely. Otherwise, as long as watch 2.0 and above, activate your session. Go ahead and activate your connection between the watch and the phone and the watch. All right, so that's the purpose of this right now. Now let's do this. Let's implement a method to send a message. All right, so what we're going to do is I'm going to add another method here for sending a message. So say func send. Message will be string : any, right? And returning a void. All right, we'll just do a session.send message. All right, and message will just be message. Reply handlers, we're not going to worry about any reply handler right now, so we'll say nil. I'm going to actually dump the error handler portion and rewrite it this way as a completion handler. And inside of it, we'll just say print error.localized description. And let's just clean up any issues here. There. One too many there. There we go. All right, so that's our basic send message right there. So now what we're going to do is, so I need to point something out here with the basic methods that were auto-generated here. So these three methods are for the phone. On the watch, it only wants this method. It doesn't want these two. So what I'm going to do is I'm going to make these two methods only visible to the iPhone side of things by doing a #if OS is iOS and doing a #endif for these two methods. All right. Now let's initialize our data. I'm going to do it in here. I could do it anywhere I want, but I'm going to do it in here. So I'm going to create a method, func init fake details. All right. And I'm going to empty out my array. So I'll say programs.remove all. All right. Now I'm going to say, we'll say let prog obj equal program object. All right, instantiate it. And then we'll say prog obj dot init with data. So I'm just going to hard code. I'm just going to say that the life of a banana. Speaker is monkey. From, we'll say, like Friday, October, let's say 31st at 10, all right, and then 2:11, and we'll say monkey will teach us the life of a banana. You can see I'm getting really creative here with my details. And then we'll say programs.append for prog obj. Now let's say let prog obj2 initialize or instantiate a program object. and we'll say prog obj2 dot init with data. And so this will be the life of a donkey. Speaker is donkey. And we'll say Friday, October 31st at 11 a.m. to 12. And we'll say donkey will bore us with his life story. And we'll say programs.append for prog obj2. All right, now the third one will be, we'll say let prog obj3 equal program object instantiated. And we'll say prog obj3 dot init with data. And so we'll say the hunt for food by Yoti. Say from Friday, October 31st at 12 to, we'll use 1300 hours. Details, Yoti will enlighten us with his search for prey. And finally, do one more. We'll say let prog obj4 equal program object instantiated. And we'll say prog obj4 dot init with data, and we'll say Walla in his life as a koala. We'll say, of course, speaker is Walla. And from Friday, October 31st at 1300 hours to 1400 hours. We'll say Walla will, actually his spelling is that, so let's fix that. Will show us how his life is better than a sloth's. Now, I'm just being silly with all of these different programs, but let's just add this. So we'll say, oh, I forgot to do the one above as well. So we'll say programs.append for prog obj3, and also programs.append for prog obj4. All right, so we have all of our stuff here. Now, what we're going to do is we want to fire off this data to the watch. The moment that this data has been created, let's fire it off to the watch. So now we're going to take advantage of encoding and decoding, the two methods we added to our program object class. So the first thing we're going to do is we're going to say ns-keyed archiver dot set class name to program object for, and then program object dot self. What this does is it tells ns-keyed archiver that when the data we're about to encode, basically this entire array of strings that we just have above in this method, we're going to give it, we're going to specify that the data structure for this object is basically the program object class. And here's a label to associate it with. Now, let's go ahead and archive our data and convert it to bytes. So we're going to say let program data equal try for nskeyed archiver dot archived data. We'll say with root object programs, all right, requires secure coding, true. And then finally, let's send this off to the watch by saying send watch message for program data. Now, this method hasn't been created yet, so it's giving us an error because we're about to create it right now. Okay, so we're going to create a method. This is our last method for this class, and we're done. For this particular class, that is. So we're going to say func send watch message, passing in the argument MSG data of type data. Now this is going to fire it off, but so long as it has, just gonna put a little underscore here. There we go. That should get rid of the error. So now we're going to say let current time equal CF absolute time get current. All right. We'll say if last message plus half a second is greater than current time, then return. Meaning we need to have a little bit more of a gap between attempts to send this message. So now let's go ahead and send this message. We'll say if WC session, actually really session dot is reachable. Let's do a little print statement for debugging purposes. So print sending watch message. Don't have to, but I'm going to do it for debug purposes. We'll say let message equal square bracket. Now my key will be prog data. My value will be MSG data. And we'll say session dot send a message. It will be message reply handler nil. And I'm going to omit the error handler portion as well. There. All right. And we'll just do a last message equals CF absolute time get current. Okay. So this method for sending our watch message is going to try and brute force send this message. Now it's going to wrap our program data, right, which has been converted to bytes, into a key value pair, and the key for this data will be prog data. So now on the watch side of things, it needs to be able to receive this data and be able to do work with it. All right. So at this point, we're done with connection provider. All right. It has everything we need. All right. Now, what we're going to do is we're going to be working on the watch side of things to get this done at this point. But we still have a couple more things to do to finish off the phone side of things here. So what we're going to do is we're going to implement a new class. So I'm going to right click and say new file. We're going to say iOS Cocoa Touch class. And this one will be called program view model. It's a subclass of NSObject. Give it a home. All right. Now, what we're going to do is we're going to implement an observable object for basically its main purpose is to handle the connection provider that we just created. So I'm going to replace NSObject with observable object. All right. And it's going to be a final. So nobody can reinstantiate. It's a final class, program view model, extends observable object. And we're going to say private set var connectivity provider. Extends connection provider. All right. Now we need an init. We'll say connectivity provider extends connection provider. We'll say self.connectivity provider equals connectivity provider. And we'll say self.connectivity provider.connect to initialize the connection. All right, now we're done with our third class, support class here. So now what we can do is actually build out this app on the iPhone side at least. So now what we're going to do is we're going to move over to content view and start doing some of these things here. So move over to content view .swift, and we're going to change things up a bit. We're not going to use the basic hello world. I'm going to add a couple of class variables here. So first thing I'm going to say is let view model equal program view model, passing in connectivity provider, colon connection provider instantiated. There. And we'll say let connect equal connection provider instantiated. All right. Now I'm just going to create a basic home page. So I'm going to replace hello world with the text conference planner. And this will be a navigation view. All right. Inside of it, we'll have a VStack. And we'll just put a tab on our text there, just for readability. Keep the padding. And I'm going to add a navigation link. Destination will be program view. Now, right now we haven't implemented program view, so I'm going to be setting it up so I'm passing the view model over. All right, so I'm going to do that. It's going to give an error. And on appear, so for navigation view, we're going to add a dot on appear. And here we'll say connect.connect. All right, so we've written a lot of code. We still haven't ran a single line of code yet, but fear not, we will get to soon. Okay, now in the program view page, the sub page here, we're going to implement having a list view to display all of our stuff. So first off, we have here struct program view. What I'm going to do is I'm going to create a custom cell first off. So we'll say struct prog view extends view, and we'll say var prog extends program object. All right, we'll say var body extends some view. All right. And now what we'll do is we'll add a VStack in here. It's going to stack all the items. So we'll say text, just the text, which will just be /prog.title. Its font will be .headline. Its foreground color will be .blue. And I want it to be its .frame. So I want it to be like left justified. I don't like the center justified default of it. So .frame, I'm just going to hard code it with like a width of 200, height of 30, and .leading. Also, it wants the exclamation mark for title. Now I'm just going to copy and paste for the others. So the second will be prog.speaker. This will be subheadline. I'm going to change its text to be green. And keep the frame there. And we'll do another paste. This will be prog.from. And it'll also be subheadline. This one will be red. And keep the same frame. And finally, 2. And be subheadline as well. And this will be black. And keep the same dimensions. All right. Now, let's set up our list. So inside program view, we're going to have an observed object. Right? Var view model extends program view model. And at state, we'll have a state var for our array of data. So var programs extends an array of program objects. We'll start off with an empty array. Okay. And I'm going to get rid of this preview provider. I don't really care for it. Now inside body, we're going to have a vstack and we'll say text we'll say conference program. And after that, I'll put a list. Programs id : /self p in, and we'll just instantiate a prog view passing in prog p. All right, so that's our list. To polish it off, we need to retrieve data. So for vstack, we'll do a vstack.onAppear. So first thing we'll say is view model .connectivity provider .connect, so launch a connection, and view model .connectivity provider .init fake details, and finally self.programs is equal to view model .connectivity provider .programs. All right, so we have enough to run and see this thing in action. And of course, silly me, I got a little excited here. I forgot that we didn't really do our navigation link properly. So we have to add in a text to say program or something to click on. Do quick command B to build. There, build succeeded. I'm going to choose the iPhone 12 Pro just on its own for now. Let's just see this in action. Verify that we have our data hard-coded. All right, so there we have our iPhone app on and program. There's our basic list of data. So we know that this thing works. Now the purpose is to get this onto our Apple Watch, right? So I'm just gonna hit stop. I'm gonna actually kill this simulator because what we're going to do is we're going to create a pairing for simulators. So now we're going to be moving into the Apple Watch side of things. So we need an Apple Watch simulator here. So we need to have it set up so that the phone and the watch are paired as a new simulator. Now to do that, what you're going to do is you're going to click on your simulators and go add additional simulators. I actually already have 2 pairings here. I have I called it iPhone 12P Max plus watch, iPhone 12 Pro plus watch. So I've already created a couple. I'm going to use the second one, the Pro plus watch, but I'm going to teach you how to create your own. So I'm going to say add additional simulators. And what will happen is that this will pop up, this window here, and you're going to hit the plus sign. So make sure you're under simulators and not devices first of all. You can see a ton of simulators here. I'm going to say plus. And what it's going to do is ask you to give it a name. First thing you do is check off paired Apple Watch. You choose the latest OS version that you want. I'm going with 14.4, but of course this applies to iOS 15 as well. I'm going to call it iPhone 12. Actually, no, I'm going to create an 11. You do 12. I'm going to create an 11 because I already got a couple of 12s. I'm happy with them. iPhone 11 Pro plus watch is what I'm going to call it. And I'm going to choose an iPhone 11 Pro. Okay, so my device will be iPhone 11 Pro. If you change your device, notice that the checkbox goes away. You got to make sure you check the checkbox paired Apple Watch. You hit next. Now it's asking you to choose your Apple Watch. I'm going to choose an Apple Watch 6. Series 6 40 mil. And call it, we'll say iPhone 11 Pro. Actually, I'm going to reverse the name. I'm going to say Watch S6 plus iPhone 11 Pro. WatchOS 7.2 is good enough. Hit create. Right? And so now you should see, and you see it here in this list, 11 Pro plus watch, and you're good. So notice that when you go to your simulator choices, 11 Pro plus watch, right? It's there now. So now you can start using this simulator instead. All right. And you'll notice that under WatchKit, you'll see Watch S6 plus 11 Pro as well. All right. So you're good. Now I'm going to be using my simulator, which is iPhone 12 Pro plus watch. All right. And if I hit run again, I should see this app over here. It's not going to launch anything for the Apple Watch yet because nothing's done there yet. But basically I have my entire Conference program up and running for here. Okay. So now we're ready to do things for the Apple Watch side of things. And to do that, we're going to have to do, we're going to need the 3 objects that you see here. I'm just going to point them out again. So program object, connection provider, and program view model need to be visible to the Apple Watch, right? Because I try and start using these guys right now, it's going to complain. It's going to say these objects don't exist. So I have to go to my project settings, and I'm going to click on the target here for the WatchKit app. All right, and go to build phases. Sorry, yeah, actually build phases is what I want. Actually, it's the third one there, extension. So this is what I'm looking for, compile sources. And you notice that it has all the files here. These are the same files listed here under my Watch app. All right, let's get the plus sign. I'm going to add these 3 items here. Program object, hit add. Plus again, connection provider, hit add. I'm going to hit plus sign again, program view model, hit add. So now I have my 3 objects that I created on the iPhone side of things. I'm going to be able to reuse them here instead of having to create them from scratch. which will just be a duplicate anyway, so we're just duplicating things. But this is a key thing here, because in order to do things on the Apple Watch side of things, we need to have these files available on both the watch and the phone. So now that I have this in play, I can go ahead and start building out my Apple Watch app. All right. So you'll notice here that on the Apple Watch side of things, we already have a content view. So in SwiftUI, things work very similar to on the watch as to the phone. So I can continue on with what I have here. So what I'm going to do is I'm going to add another content view. I'm going to right click on this folder. I'm going to say new file. And this will be a SwiftUI view. I'm going to call this prog content view. All right, hit create. So now I have here both of my content views that I need. I'm actually just going to drag prog content view to be next to content view. So in the same spot. I could create a folder. I'm going to leave that for now. And I'm going to start with my content view. All right. And I'm just going to implement a view model, program view model object. So I'm going to say let view model equal program view model. Its connectivity provider will be just instantiating connection provider. All right. Now inside here, I'm going to set up a navigation view. Now notice we're on the watch side of things now. All right, so you have to keep track of where you are now in the project. So now I'm on the watch side of things. I'm going to put a VStack in as well. All right, and the text will just be watch planner. All right, and it's going to have a navigation link. And destination will be, I'm going to drop the label from it. So destination will be prog content view, but I'm going to pass in a view model, type a view model. And we'll come back and fix this. It'll probably give an error. That's okay. We'll say text program. Give it a padding of 50. All right, it's going to complain. That's okay. Just do a Command S to save the file. We're going to move over to our prog content view. It's going to be another list view again as well. So switching over to prog content view. And you could basically copy and paste your prog view from program view here, program.swift, if you want to. I'll just retype it. So I'm going to say struct prog view extends view. I'm going to pass in a var prog as a program object. All right, do a var body extends some view. It'll be a VStack. And within it, we'll do a text for /prog.title .font headline .foreground color. Oh, forgot my closing round there. Foreground color will be .blue, and .frame will be width of 200, height of 30, alignment.leading, and then just copy and paste it for the other three items. So the second one will be prog.speaker, subheadline. This color will be green. And then we'll say this one will be prog.from, another subheadline. This will be red. And finally, prog.to, subheadline. And this will be black. Okay, so we have our prog view, identical to what we had in our phone side of things. Wasn't going to change things up there yet. Now, we're running something very similar here to what we did in our phone side of things. So, scrolling down to prog content view, I'm just going to dump this right here. We don't need the previews. It's going to say observed object. We'll say var. We'll say view model is program view model. We'll do another state. We'll say state. Basically, it's almost the same thing. Basically the same thing as what we did before. So state var programs extends an array of program objects. Set it equal to an empty array. All right. Now, inside our body, we'll do a VStack. Our title here will be conference program. And we'll have a list right below it. Programs, comma, id colon slash dot self p in, and we'll just do another prog view for prog p. All right, we'll do an on up here for the VStack again. So we'll do view model dot connectivity provider dot connect. We'll do self.programs equals view model dot connectivity provider. Now this time dot received programs. All right. So let's save everything. Let's build it. Make sure no errors. Fix all the errors that pop up. Looks like build succeeded. All right, so now we still have one more method to implement. It's very important. We got to jump back to connection provider. All right, and so inside connection provider, we have here a method called send watch message. So it's sending the message to the watch, but we don't have a method here to receive the message and process the message, and that's key. So we're going to implement a method called did receive message. Did receive message. I gotta make sure I get the correct overload. This looks like it's the one. Hit enter. Just gonna double check. So we got session, WC session, did receive message, message string any. This is exactly what we need. Drop the word code. It's gonna do a print debug statement. So print, we'll say entered, did receive message. All right. And of course I can't spell receive, so fix that. Just for my own personal debugging purposes. Now what's going to happen is that this is a delegate method, part of the watch connectivity protocol. So whenever a message is received, whichever side it's on, it's going to fire this method. All right. Now if you look above here, actually we still have it visible here under send watch message. We embedded our message with a label called prog data. So I'm going to check to see if this is the message we got. We'll say if message of prog data, make sure you spell it correctly, does not equal nil. All right, we can go ahead We'll enter it. I'll just do another debug statement. Well, first off, before I do, let's just actually grab the data. So we'll say let loaded data equal message of prog data. All right. Now, I'll just do a little print statement now just for debug purposes, just in case this crashes. So we'll say print prog data. You don't need these print statements. I'm just doing it for my own debug purposes in case things go wrong. No reply handler. So I know that this is the one, because there's another overload for the older version of this that actually had a reply handler. We don't need it for this implementation. So if I scroll up, actually I'll come back to did receive message in a moment. Now, and actually here, this is init with detail, init fake details, right? We did an NSKeyed archiver, we set the class name, and then we called NSKeyed archiver archive data. This encoded the data and is sending the data off to the watch. Now we're in the opposite of it. Now we're receiving the data here in did receive message. So we're going to first off say NSKeyed unarchiver. So unarchiver, which is the opposite of archiver, dot set class to program object dot self comma for class name program object. Make sure you spell it the exact same way you spelt it above in init fake details. And now let's go ahead and grab this data. We're going to say let loaded person equal try for NSKeyed unarchiver. Now this is going to call the decode method in our program object. So actually it's NSKeyed unarchiver dot unarchived array of objects of classes, and we'll just put an array of program object dot self. That goes inside. There we go. From loaded data as data, right? And then outside of it as an array of program objects. All right. Now that we have this, at this point, we should have our data. So now we're going to say self dot received programs is equal to loaded person. I'm just going to put a little print statement, print program received, just for myself. All right, just do a command B to build, make sure everything is okay. There we go, build succeeded. All right, now it's time to run this thing. So final product here is how do we run this together? All right, so first things first, we have here our iPhone 12 Pro Plus watch. This is under our M9 watch connectivity target, right? So I just chose iPhone 12 Pro Plus watch. I'm going to hit run. All right, it's going to load up. We're going to see this thing. It'll come to the home page in a moment. All right, you're seeing little debug messages about already activated. It's good. Now I want to run the watch. So I'm going to hit my target here. I'm going to choose my watch. Now you'll choose whichever one you want. So I'm going with Apple Watch 6 40mm. And I'm going to hit run again. I'm not hitting stop. I'm going to hit run again. All right. And now it's going to install this thing on the Apple Watch. So now I have my program on both my phone and my watch here. I'm going to hit program, let it load this screen. Notice it says program received, hit program, and there we go. And there you go. And that's watch connectivity. Now you notice in this application there was a lot of typing, very little running. And you may find that you might be running into problems here with the connectivity. So it's just a matter of just starting and stopping it again, just trying to figure out where things went wrong. But I'll tell you, in these newer versions of iOS and watchOS, they've really fixed up the bugs in terms of watch connectivity. So you shouldn't really have too many issues getting this thing up and running. All right, so that's it. Until the next tutorial, take care, have a good one, and I'll see you in the next tutorial. Take care, and bye for now.